This little video is going to take you through the Physics Internal 3.1. We're just going to discuss in this video the standard itself. So the title of the standard is Carry Out a Practical Investigation to Test a Physics Theory Relating Two Variables in a Non-Linear Relationship. So in terms of the big idea here, it's quite similar to 2.1. We're going to look at two variables which are going to give us a non-linear relationship. So you will have already looked through the information for the specific 3.1 portfolio that we are going to do at St Cuthbert's. If not, you'll find this in our Google Classroom. We're going to do a portfolio of experiments again this year like we did at level 2, but this year we're only going to complete 3 experiments. There will be no practice. So to gain an achieved level, you need 2 out of the 3 experiments at the achieved level. To get merit, you need 2 at merit and 1 at achieved. And to get excellence, you need 2 at excellence and 1 at achieved. Same as last year, there's no reassessment opportunities. So you need to be really proactive, make sure that you understand what it is you're doing before the day. And if you've got any queries, don't leave it until after you've finished your write-up. Make sure that you come and see me or Mr. Bryden, clear up any difficulties that you've got. So we've said there's some similarities between 2.1 and 3.1, and there is, but there's also a lot that is different. The first and most important thing is this year not going to be given a method to follow. So you will need to plan what you are going to do on the day when you get here before you get here. We'll just have a look at an example of an investigation. Okay, so I'll let you read through that for a few moments. So in actual fact, this investigation does give you quite a lot more detail probably than some of the ones that you have seen in the document that you've looked at. You may get a diagram, you may not. You may just get a statement that says investigate the relationship between 2 given variables. So you can see this time, whereas with 2.1 writing a method wasn't important, writing a method step by step, what are you going to do, how are you going to do it, what are you trying to investigate, is going to be crucial here. And the big difference that we've got this year is that you and the people next to you may not be doing exactly the same investigation. You may have the same equipment, you may have based it on the same initial aim, but you may not be doing exactly the same experiment, and that's fine. Okay. So if we look at the standard, as with most NCA standards, it doesn't really tell you a lot. We've got carry out a practical at the achieved level, carry out an in-depth practical for merit, and carry out a comprehensive practical at excellence. So we'll take each one of those levels and we'll have a look at them in a little bit more detail. So if we look at the achieved level first, if we look in a bit more detail, carry out a practical investigation actually involves 4 things. First thing is collecting data relevant to the aim based on the manipulation of the independent variable over a reasonable range and number of values. Okay, so this is the very first thing you're going to have to do at all levels. So what does this actually look like? Well, these are the things that you might want to think about to fulfill that part of your write-up. Which variable should be the dependent and independent variable? How have you decided upon those variables? How will the value of these variables be set? How will the independent variable be measured? What equipment are you going to use? How accurately does it need to be measured? You need to write down a valid method for collecting your data, and like I said, this may not be the same as the person next to you, the person in the next room. Okay, it is your investigation. You need to state some values for this independent variable. You need to make sure you've got enough data to cover a reasonable range and that they're well spread out. hopefully evenly spread out across that range. But again, deciding on what values you're going to use is your decision, and you've got to justify it. So you're going to take some measurements of the dependent variable, make sure you've got some units in there for all of these things. You know, and again, how are you going to measure the dependent variable? How accurately are you going to measure it? What equipment are you going to use to measure it? Why have you made all of these decisions? So the next part of the standard says you need to determine appropriate uncertainties in raw data. So this is the part where you're going to be experiencing something that's totally new. So we haven't really dealt with uncertainties before. You may have had the odd question in class where it said, I think at level 2 you had a couple in your notes where it said, you know, the uncertainty is plus or minus 5%. Okay, so those are the things that we're looking at there. So raw measurements have got to be recorded with an uncertainty, and we'll look at how we do this in a later video. Like I said, you may have already seen measurements with an uncertainty attached, but again, we will look at this in a little bit more detail in a further video. When you're looking at uncertainties, you again are going to have to decide how accurate you've been in your measurements and how much uncertainty you're going to apply. And again, this may be different from the person next to you. It may be different from every other group. Okay, but it's your decision and you need to justify it. Okay. Part 3 at the achieved level, obviously you're going to have to draw a graph now, and you're going to have to consider the uncertainties, and you're going to have to come up with a relationship again. So either an equation it may be, or it might be a relationship or a value of a physical quantity that you can actually determine from your graph. So you're going to be carrying out a transformation again, which will allow you to draw a straight line graph, and this time you're going to be plotting them using error lines, and again that's something you haven't probably come up against before, but we will look at that in a further video. So if you're just looking at the achieved level, the last thing you need to do is provide a conclusion that states the equation or the value of the physics quantity determined from the graph, and include a comparison with the physics theory. Now this is the bit that's probably new for 3.1. So your equation this time is going to include some reference to either the equation that suits your straight line, or you may be using your graph to identify a specific quantity. I don't know, maybe the value of G or some other value. What you need to do now though is look at how accurate your data is. So if you look at your either equation, you might have been giving a theoretical equation to work with as well. So look at the theoretical equation. What value should you get for certain variables in your equation? How close are you? If you take into consideration your uncertainties, are you within that range of uncertainties? Again, we'll be looking at this in a bit more detail in a further video. So again, this stuff with the uncertainties is the real difference between level 2 and level 3. So that pretty covers you those 4 main points at the achieved level. When we get onto our in-depth practical, we've got to describe the control variables or other variables that could have significantly affected your result. So what other quantities in your experiment, other than the 2 that you have measured as your dependent and independent variable, could have had an effect on the result if they were allowed to change? Now the important thing is here that you don't just trot out a whole load of, well, this could have changed, this could have changed, this could have changed. You've got to think about these as you're doing your experiment, because what they're looking for at the merit level is for you to minimise the effect that these things could have before you started taking your results. So it's no good at level 3 saying, oh, well, this was wobbling, this had a massive effect on my results, and you didn't do anything to stop the wobbling. They're looking for you really to preempt these things now and actually do something about it, make it have as little an effect on your results as you possibly can before you start. Okay, so as it says at the bottom there, if there's a control variable that can be controlled, it must be. Okay, don't say next time I would have done this. You need to do this and make your experiment as accurate as you possibly can. So using techniques to improve your accuracy of your measurements. So each measurement you take, you need to think, if I kept repeating this experiment, would I still get the same measurement, or is there quite a lot of variation in there? If there's quite a lot of variation in there, obviously repeating and averaging, multiple measurements, all of those types of things that you talked about at level 2 are going to be crucial, and they need to be done. There may be other processes that you'll have to use to make sure you're getting accurate results, and again, those should be done and they should be written about. So things like parallax error, zero error, all of those things that you've talked about at level 2 to ensure both accuracy and precision in your measurements. Again, a new thing for this year is your uncertainty. So once we've transformed our data, we're going to have to do some transformations on your uncertainties from your raw data as well, and we'll talk about that in detail in a further video. And those uncertainties will need to be expressed also when we're looking at your graph as well. So when we've processed the uncertainties in our raw data, done our transformations, we do transformations on the uncertainties as well so that we can plot error bars on our graph. And we also now have to not only put a line of best fit on your data, but you also have to put an error line on the data. And we'll look at that in another video. So once we've done all this stuff, we need to give a conclusion that makes a quantitative comparison between what we get experimentally and what we've got theoretically. So we actually have to attach values to this. So we use the uncertainty that we get in our relationship, and this time your equation that you get from your line graph will also include information on the uncertainties in the overall equation. You need to look at that against the theoretical values, or it may be a physics quantity. And when you've done some manipulation with the uncertainties, you can say how close is your experimental value to the actual theoretical value. Does it fall within the range that your uncertainty allows for? And then you can make a comment about how accurate your experiment was, how accurate your data was. The very last bit that is really where the focus of the excellence level comes on, and this is your comprehensive practical, is the discussion at the end. So this is addressing all the issues that were critical to your investigation. Now, you're not going to always necessarily write all of these things, and it's certainly not limited to these things, but some suggestions are things really that would enable someone to look at your experiment and judge how reliable is your investigation. So again, you can come back to talking about variables. There may have been things that you couldn't control or that you couldn't completely control that you want to talk about. Is there a limit to how applicable the model that you're working with is to the real life situation? So you would have been given some kind of real life situation. So if we go back to Moana, I think she was talking about a confidence course. So, you know, the size of the logs and the setup of the confidence course, how realistic is your model that you've got maybe a ruler hanging on 2 pieces of string? How realistic is that, or how closely does it model the real life situation? That's probably one of the things that you're going to be able to talk about most confidently, I guess, at the end. Are there any difficulties at extreme ends of the independent variable? So are there any odd things that you noticed happening as you got towards the low end of values for your independent variable or the high end? Are there constraints on how far your model can go? So that's another one that's quite nice to think about and write about towards the end. Any unexpected outcomes of processing the results? Did you find any strange outliers? Did you find any strange things with your intercept on your graph? Where might they have been caused from? What effect does that have on how valid your conclusion is? How valid is your experiment? How valid is your model? Okay, so what I'll do in subsequent videos, we'll actually use Moana and her swinging log as the actual example, and we'll go through that experiment piece by piece and see where we can pick up things. What I want you to be very careful of, though, is that you don't think as long as I trot out the same stuff that Ms. Nourish has talked about with this confidence course and swinging log idea, I'll get excellence. Because remember, only certain things will be relevant to certain experiments. The next 3 experiments that you do, some of those things may not or totally will not be relevant. Okay, so you can't just keep trying to rote learn things and keep trotting out the same thing experiment after experiment, because it's really not going to work for level 3. Okay, but as long as you've done some background work for this, and you've sort of been really proactive this year about doing it, don't just expect to be able to turn up on the day and go, right, what am I doing now? Then you should get on pretty well with this.